Hello students, welcome back. As you know, last class we were studying about vacuum gauges, which are devices used to measure low pressures, very low pressures existing in vacuum devices. Previous class we studied one type of thermal conductivity gauge known as Thermocouple gauge. Okay, so how thermal conductivity of a gas can be used to measure pressure, we have seen. Today we will see another gauge, which again is based on thermal conductivity measurement, used in a indirect way, which is called a thermocouple gauge. So let's see the working of a thermocouple gauge. Here thermo EMF produced by the device is used to measure the pressure in a entirely different way. Okay, so entirely different way. So let's see how this is done, and for that we use thermocouple. So in fact thermocouples, as you know, they are basically combinations of different metals. It can be metals or it can be non-metals. You combine together different wires made up of different metals or non-metals, alloy metals. Alloys means combinations of combinations of mixture of different metals, and they are connected at different ends, and you make junctions, and you can keep them at different temperatures, provided that there is a temperature difference. That means both junctions are not at the same temperature. So if dissimilar temperatures are maintained, then what we get a potential. We get a potential EMF across the wires. So that can be measured. So it varies with the temperature difference. So this device, this setup is called a thermocouple. Okay, it's called a thermocouple, and the only condition is that the temperature should be maintained at different levels. One side it is 0 degrees, other side you can increase the temperature to any level. Depending on the temperature level, different voltages will be shown across the wire. That can be measured using an appropriate voltage measuring device. So this is a phenomena, in fact, discovered well in the year 1821 by one of the German physicists, Johann Seebeck. Okay, so often it is called as Seebeck effect or Thomas effect. So like that. So this Seebeck effect is nothing but how the temperature difference between two junctions of a dissimilar wires connected together, that effect, that voltage creation is called essentially Seebeck effect. Okay. So let us see how that thermo EMF or thermocouple is made use in a vacuum device. Suppose you consider the figure. This is a vacuum chamber. In fact, one side is connected to the vacuum pump, and this is the vacuum. This is the thermocouple. One junction is here, other junction is outside. So this junction is kept at a high temperature by connecting with the heating element. This junction is kept at a high temperature. Okay. So initially pressure is high, so thermal conductivity of the gas will be high. So what happens? Temperature will remain at a constant value because there is a constant transmission or radiation of thermal energy to the outside. Okay, so temperature will be a constant. So thermo EMF is also a constant, or you can say a base level. Let's see the base level of thermo EMF, as indicated by the this device. Okay. So as the pumping now starts, when pumping starts, what happens? The air density decreases, so thermal conductivity decreases. So when thermal conductivity decreases, what happens? Temperature of this junction will increase. Of course, when temperature of this junction increases, automatically thermo EMF will also increase. So when pressure goes down, when pressure decreases, thermo EMF, you can see it is increasing. So there is an inverse relation between the thermo EMF and the pressure. Okay. So we can make appropriate relationship or you can make appropriate calibration of thermo EMF and pressure. So the table made by measuring the thermo EMF and pressure is called a calibration table. So calibration table is a measure of, or you can say thermo EMF shown in the calibration table is a measure of the pressure. So in fact, when you get the device out in the meter, the moving coil meter, only pressure will be marked, no voltage will be marked. Instead of voltage on the dial in the meter, voltmeter, pressure will be marked. So pressure is, or you can say voltage is an indication of pressure. So by converting a galvanometer or a voltmeter, you can convert into a pressure meter like that. Okay. So here pressure is measured in terms of thermo EMF, but it indirectly is an indication of the thermal conductivity of the gas. Okay, because gas density is changing. So as the gas density decreases, its conductivity also decreases. So junction temperature increases, and which leads to increased thermo EMF. So that is the working principle of a thermocouple. And you can write in a step-by-step manner like this. There is a device working on the principle of thermocouple, in which one of the junction is kept at a gas temperature, that is inside the vacuum chamber, you can see as shown in the previous slide, and the other junction is outside in air, you can say. Thermo EMF produced is a measure of the temperature and hence the pressure inside. So usually this is a very important point. Usually thermopiles are used because thermopile is a combination of number of thermocouples. If we use a single thermocouple, then the thermo EMF developed will be much small, usually of the order of microvolt. Okay, so microvolt is not enough to, it is not a measurable quantity. So what we do, usually number of thermocouples are connected in series, they are called thermopiles. Thermocouple will give us sufficient voltage which is measurable. So usually in practice thermopiles are used in a thermocouple device instead of a single thermocouple. So this is how it looks like, and measured thermo EMF is converted into corresponding vacuum pressures existing in the chamber using a calibration table. That is the calibration table which I mentioned. So this also depends on, the thermo EMF also depends on thermal conductivity of the gas containing the vacuum container. So of course thermal conductivity in turn depends on the pressure. So in fact the interior view of a thermocouple you can see here. The outer leads are shown in the second figure, and inside what is actually fitted is shown here. This is the thermocouple junction and it is kept in contact with the heating element. So temperature will vary with the air density existing. Okay. So this part is connected to the vacuum chamber using a screw system. You can rigidly and tightly with a leak proof you can connect to the vacuum chamber. So these are the two figures which clearly explains the nature of the device. Okay, so this is the working principle of a simple thermocouple. Okay, very simple. And the next class of vacuum gauge is called ionization gauge. Here what is measured is the ionization current, not the thermal conductivity. You can ionize a gas by passing appropriate voltage or passing electron through it, or continuously pass some electron stream through a gas and ionize them, and measure the ionization current. By measuring ionization current, one can estimate the pressure accessing the chamber. So usually ionization chambers, ionization gauges are of two types. One is called cold cathode ionization gauge, and second class is called hot cathode ionization gauge. The basic difference is, in first case cathode is not being heated, and in the second case cathode is being heated. That is a difference, and accordingly the working principle will also vary. So let us see the first one first, called cathode ionization gauge. The another name of this device is penning gauge. Okay, so let's see how it is working. So this is the interior structure of a penning gauge. You can see two cathode plates. They are made up of usually of nickel like that or steel. They are plates actually. They are connected to the negative potential of the battery. The applied voltage will be of the order of kilovolts, and you can see at the middle a ring. This is a ring structure, not a plate actually. It's a ring made up of some thin wire, some metal wire, and the space in between them is blank. Okay. So what happens usually is when a suitable voltage of the order of kilovolt is applied, what happens is there will be an electron discharge between the plates. Because we have a cathode plate here, we have an anode ring here. Obviously, when sufficient voltage is applied, what happens? Electron discharge takes place from the cathode to the anode, because anode is positive. But what happens? Anode is a ring structure. So most of the electron discharging from the cathode to the anode can simply penetrate through the ring and reach the other plate. Instead of discharging on the ring, what happens? The electron discharging from the first cathode goes straight away down to the second cathode. So at the second cathode, what happens? Potential is again negative, so electron rebounds. So it makes its upward journey. Okay, it makes a transition to the upward. Again reach near to the cathode plate, upper cathode plate. Again they get repelled because polarity is same. So this way electron execute an oscillatory motion between the plates, and finally they may get discharged on the anode ring. So anode ring structure is so thin, it is deliberately made like that, so that electron don't get easily or readily get discharged. They remain continuously inside the chamber. Why this is so? This is so because electron is oscillated to make possible the ionization of the gas molecule. There is a lot of gas inside which we want to evacuate, that is ionized. Okay, so in order to enhance the ionization probability, electron is continuously oscillated by using this ring. Okay, in order to enhance the ionization further, there is a magnetic field, a transverse magnetic field is kept. Magnetic field is not shown here, it is outside. A magnet is kept so that field is, due to the presence of magnetic field, electron execute a circular motion. We can say a helical motion. So there is two kind of motion now. One is oscillatory motion between the upper and lower cathode plates, and there is a circulatory motion. So collectively you can say it's a circulatory oscillatory motion. Okay, there is both a helical motion and there is an oscillatory motion. Okay, so this helical plus oscillatory motion leads to enhance the ionization of the gas. So that will increase the sensitivity of the gauge. Okay, sensitivity of the gauge is increased and it will readily measure the pressure. So once there is the more the ionization, current. Once particles are gas molecules are ionized, they become positively charged, and they readily reach the cathode plate. Okay, they readily reach the cathode plate and get discharged. So that will create a current in the outer circuit. That current will be noted from here. So this ionization current is a measure of the pressure actually. When pressure goes down, the ionization current will be slow. Okay, there is a linear proportionality. When pressure goes down, current also goes down. In the previous case, thermo EMF case, it was the other way. Okay, when pressure goes down, thermo EMF goes high. But here there is a linear proportionality. The same proportionality we can use to measure, to make a calibration table, and from the calibration table, pressure can be easily measured. Okay, so this is the essential working principle of a penning gauge. So these are the main points. There consists of two cathode plates, upper plate and lower plate. Anode ring is fixed in between the plates, and in addition to this, there is a transverse magnetic field, but that is not shown in the figure. Electrons are accelerated from cathode to anode ring, but electrons get befooled. Okay, you can say befooling, making fool. So because electron not get easily discharged. So instead that they get overshooted down to the lower plane. Electron cannot immediately reach the anode due to the special anode geometry. So that is obvious from the figure. And electron tends to move in a helical trajectory. Helical as well as oscillatory. You must understand it. Okay. Both oscillates and both helical motion. Due to this, ionization property increases. Ionization creates an ion current in the upper chamber. This ion current is a measure of the chamber pressure. So you can measure pressure up to 10⁻⁴ torr using this method. Okay, so this whole technique is used to increase the sensitivity of the device. That's the essential purpose of fixing magnetic field, fixing transverse magnetic field, and oscillatory motion. Two plates are given to execute oscillatory motion. Magnetic field is given to make a helical motion. So combined action of the electron will be oscillatory plus helical motion. Understand? So that's the working principle of this device. And this is the assignment in a thermocouple case, how the thermo-MOD is made use in measuring vacuum pressure. So you watch the video properly 2 times or 3 times, then make your own lines. Okay, or you can Google out. You will get many websites where this is explained. So frame your own note based on the readings. Okay, you can surely make. You search it out. If you have the textbook, you can get the information from textbook and make your own explanation. In your own way, you explain it. Second question is, what is the role of magnetic field in a bending case? This is also well explained. You understand the principle very well and you write in your own style. Okay, that will enable you to write the exam very well. If you simply note down from the books, that will not facilitate easy exam performance. Okay, so for better performance in exam, you understand the principle very well and write in your own way. So with this few comments, let us stop this class. Okay, thank you all.